Hi 7th graders, today we're going to work on lesson 6.1.4, solving one variable inequalities. So make sure you write that as your title on your paper and you have your book open to page 333. When you're all ready, you can play the video again. Lesson 6.1.4, how can I find all solutions? Solving one variable inequalities. In this lesson, you will work with your team to develop and describe a process for solving linear inequalities. As you work, use the following questions to focus your discussion. What is the solution? What do all of the solutions have in common? What is the greatest solution? And what is the smallest solution? Your first problem is 35. Jerry and Ken were working on solving the inequality 3x minus 1 is less than or equal to 2x. They found the boundary point and Ken made the number line graph shown below. So I see that the boundary point is 1, and it's every number less than 1 because that's the way the ray is pointing. Jerry noticed a problem. Doesn't the line at the bottom of the less than or equal to symbol mean that it includes the equal part? That means that x equals 1 is also a solution. How could we show that? Jerry said. Well, the solution x equals 1 would look like this on a number line, with the closed circle. Is there a way that we can combine the two number lines? Discuss this idea with your team and be prepared to share your ideas with the class. I would like you to write your idea down in your notebook and then play your video when you'd like to hear my answer. The way you combine these two number line graphs is instead of having an open circle on one, you would have a closed circle saying that x could be equal to 1 and x could be equal to all the numbers less than 1. Problem 36. The diagram at right shows three possible ways to represent inequality statements. Review the meanings of the inequality symbol greater than or equal to, and less than or equal to with your team. Then generate the two missing representations from each inequality described in part A through C below. So it shows that I need to have a graph, I need to have words, and a symbol for each of the problems. A is x is less than -1.5. That would be written in symbols. The way you're going to write it in words is exactly how you say it. So x is less than -1.5. The last thing I need to do is make a graph. So I'm going to make a graph, and then I need to put the tick marks on it so that I can show where each number will go. So you need to be doing this in your notebook also. And then after I'm done with this, I'm going to go back and put numbers on my number line. So I'm going to start with 0 more towards the right side because I know that my numbers have to be less than. So I will number mine and you should be numbering yours. Okay. So now I have to show that x is less than -1.5. So it's not equal to, it's just less than. So I know that it's going to be an open circle. So at -1.5, I'm going to put an open circle, which you should do on yours, and then it's all numbers less than -1.5. So I'm going to draw my arrow going towards the negatives less than -1.5. And that would be how I draw a graph. Okay, so let's try B now. I'm going to write out my answers over here for that one. So it starts with x is greater than or equal to 2. So I'm going to write, this is in words, so now I have to do a graph in symbols. So I'm going to start with symbols. X is greater than or equal to, so I'm going to draw the line underneath to represent equal to. So less than or equal to, or greater than or equal to, than 2. So this would show x is greater than or equal to 2. So I have words and symbols, and now I need a graph. I'm going to do a different one. So I'm going to draw my number line. And I'm going to put numbers on it. So I'm going to start more, I think I should start more towards the left side because it's greater than or equal to 2. So I'm going to start with 0, -1. This will be going positive towards the right, 2, 3, 4, and 5. So x can be equal to 2. You'd have to put a closed circle on 2 to show that x can also be 2, and then x is also everything greater than 2, so your arrow would have to point towards the numbers that are greater than 2. For C, I'd like you to try it on your own, so pause the video, and then when you think you have the answer for both of the missing parts, then play again and check your answer with mine. Hopefully your answers look similar to mine. So for C, x is less than or equal to 2 because the circle is closed, and you needed to write it in words. X is less than or equal to 2. The next one's 37. When is the boundary point included? Represent the solution for each of the variables described below as an equality on a number line and with symbols. A. The speed limit on certain freeways is 65 miles per hour. Let x represent any speed that could get a speeding ticket. So we need to show an inequality on a number line. So for A, I'm going to draw down here below. I'm going to start by making a number line. So if you were to get a speeding ticket, it would be going over the speed limit. So I'm going to start my number line at 65 because I know anything greater is going to be where it gets me a speeding ticket. And I'm going to count up by 5s. So next you need to decide if the boundary point is included or not. So our boundary point is going to be at 65 because that's where the speed limit is. In this case, you would not get a speeding ticket if you're going 65 because that's included in the limit, but anything greater would give me a speeding ticket. So the circle would be open for the boundary point at 65, and then it would be any speed greater than 65. I'd like you to pause the video for B and try it on your own first. For B, it says you brought $10 to the mall. Let Y represent any amount of money you can spend. So I'm going to start by drawing my number line. If I have $10, I know that I can spend all of my $10, but I can't spend more than it because I don't have the money. So I need to decide if the boundary point is included, and at $10 I can spend that $10. So I would include the $10, and then I could spend anything less than that. One thing that we need to add is the symbols. So going back to A, it's saying let x represent it. So x would have to be anything greater than or equal to, equal to 65. Oh, for this one it's only greater than because 65 we said was okay. Then for B, we're talking about y as our variable. So y is anything less than or equal to 10 because I can spend the $10 or anything less than it. Again, I'd like you to pause the video for C, and then I will show you my answer when you play the video again. says to ride your favorite roller coaster, you must be at least 5 feet tall but less than 7 feet tall. Let H represent any height that can ride the roller coaster. So it says I need to be at least 5 feet tall, so it would be okay if I was 5 feet tall, which means that that boundary point is included, so your circle would be shaded, but less than 7 feet, so I can't be 7 feet tall, so that boundary point would be closed. And then it would be any amount in between. So for this one it's a little different because it has a starting point and an ending point. To write this in symbols, I would start with my lower boundary point. So I would have 5, and it could be any number greater than or equal to 5. And then it would have to be less than 7. So this shows H is greater than or equal to, I wrote my symbol the wrong way, H is greater than or equal to 5, but H is less than 7. The next one is 38. Ellie was still working on her dollhouse. She has boards that are 2 different lengths. One long board is 54 inches. A. The length of the short board is unknown. Ellie put 3 short boards end to end and then added her 12-inch ruler end to end. The total length was still less than the 54-inch board. Draw a picture showing how the short board and the long boards are related. So for this one I know that I have, wrong symbol, I have a long board that is 54 inches. So I'm going to start by drawing that. Then I know that I have 3 short boards and a ruler that's still less than her 54-inch board. So I'm going to draw 3 short boards. And then I have my 12-inch ruler that is still shorter than her 54-inch board. So that would be a picture showing how I have my 3 short boards and a ruler related to my 54-inch board. B says write an inequality that represents the relationship between the short boards and 54 inches shown in your diagram in part A. Be sure to state what your variable represents. So for this, let's do S is equal to the length of a short board, and that can be our variable. So now I need to make an inequality. For this one I know that 3 short boards, so that would be 3 times S, plus 12 is still less than 54. So that would be the way I'd write an inequality to show the relationship between my short boards and my long boards. C says, what are possible lengths of the short board? Show your answers as an inequality and on a number line. I'd like you to pause your video and do C by yourself. What I found for the possible length of the short board is 10. So if I had 3 short boards with a length of 10, that would be 30, plus 12 would be 42, and that could be a possible length. The way you'd solve to see what S could be is you solve it for S. So I need to get S by itself, so I'm going to subtract 12 from each side, and I would end up with 3S is less than 42, and then to get rid of 3 times S, I would divide by S. I'm sorry, I meant divide by 3, not by S. And then I would be left with S is less than 42 divided by 3. 42 divided by 3 is 14. So S is less than 14, and then you would draw that on a number line. You need to work on finishing problem 38, and then you can show your teacher to get your homework 42 through 47. So finish that number line and then you're all set.